All right, welcome students. Today what we are going to be doing is going over the periodic trends worksheet. And the periodic trends worksheet, our goal is to really explain the types of questions that we can have, and then also how this type of worksheet is more in tune with a sort of guesstimating quality that can be useful in chemistry, especially with some of these questions that are just about just testing you on some basic theories about the content. So we're going to go ahead and start with our first question over here, which is to write the equation that describes the first ionization energy of calcium. And this is something that, usually when it says write an equation, like our initial thought is, oh, well, what equation? And do I have to look that up on a table? But in chemistry, it's just basically saying, like, what's the basic reaction? So in this case, it's Ca, and then we add, well, we're adding energy, but usually when we write out these types of equations, we're not going to even indicate that. And that's going to turn into Ca. Then we're going to write R plus. And then we're going to add to that the electron, okay? And that's all that these equations actually are. They're just saying, like, hey, what's the equation that indicates that we have made an ion out of this particular compound right here, okay? And, even though this question looks intimidating, this is all that we actually have to do. We just have to say, like, hey, we have the first ionization energy for calcium. So this question here is testing first calcium, and it's the first ionization energy. So you need to know that calcium has all of its electrons there, okay? And it's ionizing, which means it's losing an electron, and that's what the first one's testing, okay? The next one is going to be the third ionization energy of potassium, okay? So if it's the third ionization energy of potassium, that's going to be K. And then it's third. So since it's third, that means that it's already lost 2 electrons, okay? Because we're looking at the equation for when it loses 3 electrons, okay? So we'd start with 2 plus instead of nothing right there, okay? And then we're going to go ahead and draw our arrow. And then it's going to be A, and in this time it's going to be 3 plus. And then we have to remember to add our electrons, and I'm going to go ahead and copy this electron because I'm lazy, and then we add it in there, okay? And this is how we do our third ionization energy, okay? And this one's really testing, like, hey, if it's the third ionization energy, how many has it already lost? Okay, and in this case, it's 2. And then this same one right here, second ionization energy of lithium. And this one, to be honest, doesn't really test anything new. It's testing the same thing as number 2 is, but it's just giving extra work with it. Okay, since it's second ionization energy, that means that it's already lost 1. We draw our arrow. And then we have Li plus 2 plus our electron there. Okay, and this is just our really basic equation. Wait, did you see that? Did you see that the arrow changed? Oh my god, that's amazing. Okay. All right, so this one right here, the next one, is asking us the second ionization energy for nitrogen is 22,860. The third ionization energy is 4,900 or 4,590. Explain why the third ionization energy is higher. Okay. And this is one that really goes back to Oh shoot, I have to open up a BBB. 1 second here. This is the only program that I know that works really well with this. Okay. So this is a case where we have our nitrogen. Let's go ahead and get the draw. Let's make it big. Okay, we have our nitrogen in the middle. And we have our 2 lines. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7. And nitrogen has 7 protons. And that's pulling on 7 protons right now. Okay. It's saying that we lose 1 electron. And then we lose the second electron. So we've lost 2 electrons here. And that the energy level is this one right here with 2 electrons. Okay, so we've lost these electrons. And we lose a third. Okay. Well, what happens between the second and the third? Well, here on the second one, you had 7 protons that were pulling on 5 electrons. Okay. Oh, sorry, I lost my mind for a second. So you have 7 protons that are pulling on 5 electrons. Okay. When you try and remove an extra one from there, you have 7 protons pulling on those 5. Okay. So trying to remove an extra one from there is going to take a lot more energy because the charge or the pulling to keep those electrons is stronger there. So that's what you would try and explain there. Okay. You would look for, the charge isn't, as spread out as it was in the beginning of our equation here. Okay. And, it's more focused on those remaining electrons instead of the other ones that are up there. Okay. All right. So next is problem number 3. And this is showing boron. Okay. And it's showing the first ionization, the second ionization, the third, and then the fourth and fifth. And, whenever we get a graph, we should take a look and see, okay, what's going on here? Okay. So here we have our nice little graph. First ionization comes off. It's less than 1,000. Oh, okay. Second one, it's more than 1,000. It's, quite a bit larger. But it's not like egregiously so. Okay. And then the third, it's a little bit more than the second. And then the fourth is, oh my God, what happened? Okay. So what happened here between these two? And that's what we need to explain. And then even here, between the fourth and the fifth, even though they're similar, even though they're both large, they're both similar in their magnitude. So we want to explain what's happening between this magnitude change at some point. Okay? And so the first question is, why is there a large increase between the third and the fourth? Okay? And this is what we were explaining earlier in the graph, that the lines of force that are coming out from here are going to be fairly strong. So these blue lines, we can think of these as lines of force that are fairly strong on this inner level, whereas on this outer level, they start to weaken. Okay, so they're still coming from, I dislike that. I want a thinner line. So as they come and reach out here, these energy lines are a lot weaker than these big, thick energy lines right here, okay? So that's why we have that magnitude of difference. The nucleus can hold on to the closer electrons a lot more firmly than it can hold on to the other ones. Okay, so that's what's going on with 1. And explain how these confirm that the electronic structure of boron is 2, 3. Oh, so that's what the next part is saying, like, hey, what's going on with the electrons in boron, okay? And so boron, we have our B here. And let's get our circle. And so the 2, 3 has to do specifically with like the number of electrons. And that color won't work. Let's go with some red. And the electrons here, if we think about it, the first one that we lose is over here on the outside edge. The second one we lose is here. The third one is here. And then the inner ones are the ones are 4 and 5. So they're a lot closer to it. Okay. And that's what it's asking us to explain. Like, hey, because these ionization energies are there and they're those values, we can explain them. Okay. The last one is for question 3b, and that's to use a graph to make a prediction on this one right here, which is aluminum. Okay. So we would go ahead and we're first going to go ahead and pick up the periodic table. And we're going to look at aluminum here. Okay. And here's what we're going to do. We're going to be like, okay, where is aluminum? Okay, it's right here. It has 13. Okay. So we have 1, 2, 3. So in the outer energy level, we have 3 electrons. So we're going to go ahead and draw that out. Okay, let's go here. So Al, let's write it correctly and not like a derp derp. And then we have, oh my god, that's a large one. We have 1, 2, 3. Okay, and let's do green electrons. Okay. And then we're going to draw our electrons, and we already said that the outer level had 3 electrons. Okay. So let's go ahead and draw those in. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now we have 13 electrons. And this is wanting us to go ahead and essentially predict what the aluminum ionization energy is going to be. Okay, and it really does want us to try and predict it instead of just writing it, instead of just finding it. Okay, now that being said, and I'm scrolling back here really quickly so that I don't look at it because I want to do like my predictions here with you. Okay, but we can go ahead and double check, and I'm sure that some of you will want to double check to see how close that you are. But I would really like you to try to go ahead and make a prediction because I'm not actually going to be grading you for accuracy for this. Okay. And so we'll go ahead and we'll make our prediction here for the ionization energies. Okay. And we know that this first one, it's going to be pretty low. Okay. It's going to be fairly low. It's going to be in the 6, it's going to be in the 700s. Okay, we know this because the lecture I gave you earlier today ended up having that, and we know that it has just 1 more proton, so it's probably going to hold on to this outer level a little bit stronger. Okay, the key is that your first one has to be your lowest one, though. Okay, so our first one, let's go ahead and say that's 650. Okay, our second one is also going to end up being lower. Okay, so let's go ahead and get rid of one of them. Okay, So when we lose our second one, it's also going to be one of the lower numbers. So we're going to try and keep it in the same range. Okay. So it'll be larger than 650, but it's not going to be like, hugely larger than 650. And let me get rid of this graph so I can show you how to use it. Okay, and it might be 2 to 3 times larger, and that's perfectly fine. You can make that type of prediction. Okay, what I'm really going to be testing you is that since this is in the same energy level, it should be about the same energy level that it loses. Okay, so we're going to go ahead and say, that it's 1200. Okay, then we're going to take a look at the third one. And remember, the third one is also in this same energy level. So, if we doubled the first one, we might as well double the second one and, maybe add a little bit to it. Okay. That in and of itself doesn't matter all too much. So we'll go ahead and do 2500. Okay. And I'm keeping these numbers large and I'm keeping them round so that you guys see that I'm just kind of coming up with these numbers off the top of my head. Okay. We're looking for magnitude change versus, actual change. Then this fourth one, we now go to this inner ring. All right. Now this is where it gets real. All right. So since this is going to this inner ring here, what I want you to do is increase it by a lot. Okay. So here we had 2,500 here, and we're going to go ahead and increase this by, oh my goodness, a lot. So we're going to go ahead and say that it's 16,000. Okay. And we're pulling this number out of nowhere, but we know that this is a whole magnitude difference. Like this is 6, 7, 8 times different than this one. Okay. And then the fifth one is going to be in the same range as this other one. Okay. So it's going to be bigger, but it's not going to be a big magnitude bigger. Okay. And sorry, that's a shopping list. I'm trying to find a book for my niece. And so we can go ahead and say like, the other one was 6,500. And we'll go ahead and go 25,000. Okay. And this is going to be the chart that we're going to use. And we'll go ahead and change this one to aluminum. Okay. So now what we'll do is that we can go ahead and make a graph for it. Okay. So go ahead and highlight the graphing area. We're going to hit this button right here. And this will give us a graph. And at first, it gives us a terrible graph here, okay? Because this graph is giving us straight numbers, and it's not really showing us, it does show us a little bit. It shows us here that we have a, pretty standard upward swing. Then we have a logarithmic change. That's great. But we can also go ahead and change the axis. So what I did over here was I hit Customize. Then I went to vertical axis, and we're going to go ahead and log scale it here, okay? And the vertical axis is going to go ahead and change the log scaling, and that's just so that it goes ahead and shows us like the big magnitude change here, okay? Now notice that we have this slow curve here, slow gradual curve coming along until it hits 3, and then once it hits 4, we have this is our log change. So this is our big logarithmic change when we go from 3 to 4. And then it levels back out again. Okay. And so what you'd go ahead and do is you'd go ahead and then take this and you'd go and hit copy chart. And you'd paste in your chart. And go ahead and paste unlinked. Okay, and that way your chart's actually in there. Okay, and that's what we would be looking for here. Okay, and this is just an explanation. I hope this is able to clear up any issues that you guys might have with this worksheet. And yeah, that's it.